Okay, so let's continue our discussion in case of zero error. So when there is no object and suppose that both jaws are aligned in such a way that 0 and zeros are aligned, then we say that there is no zero. So this is the case that we have just studied. So this is the case of there is no error, and this is the case when there is no object, but you can see that the vernier scale is not aligned, but it is on the right side of 0 of main scale, and that's why this is called positive zero error. So even when there is no object, you can see that there is error and it will read some value. So this is called positive zero error. We'll calculate how to calculate this error, and after that, so after this, in this case you can see that 0 of main scale and the vernier scale is left of the main scale. That's why this is called negative zero error. This is the case of negative zero error. When there is no object, there is an error, and because 0 of vernier scale is on the left side of the 0 of main scale, it is called negative zero error. So now we need to have error correction. So whenever we'll measure object, whenever we'll measure length or dimension, this error will be always there. In case of any object, there will be this error, and in case of this also there will be this much error, this much positive error, and this much negative error will be always there. So what do? We have to make error correction. So error correction is always, the formula is that error is always corrected. Whatever error is there, will always subtract it from the reading. So whatever new reading will be there, we will subtract this error. So first of all, we need to calculate what will be the error. So let's say that we have calculated error to be, so we are saying that this is the positive zero error. So in case of error correction, so this is the first thing that we need to know, that error correction is always, what do? We always subtract error. Whatever will be the reading, will get. So suppose we are measuring from this instrument, and whatever reading will get, we from that reading will subtract this positive error, and in case of these two, error correction will subtract the negative error. The issue is that value will be different for both cases. So in case of this error correction, we always subtract error correction. Whatever error is there, will measure the reading as if there is no error, will measure reading, and from that reading will subtract this negative error, negative zero error. So the formula is same, but we calculate in a different way, because this will be negative quantity. So this gets add up, and this positive error is positive, so this is subtracted. So positive error, how do we calculate this positive error? So the formula becomes positive zero error. Let's say that it should be 2. So we'll write formula like this: n plus whatever will be the this. So let's say that the vernier scale is aligning at let's say that we know that how to read the, hopefully we know that how to read the vernier reading. So we'll read vernier reading, but in this case there is n. So this indicate value of n, where our 0 starts, from which number our 0 starts. So it start from 2 onward. So we'll write n is equal to 2. So in this case will become, our value will become 2, and then we'll take vernier count into x. What is this number x from 0 to where it is aligning with the main scale? So this becomes positive zero error, and in case of formula we write it like this n, and in our case we'll write this as 2 and then x into Vernier count, and this value will be positive, and we'll subtract from the reading whatever reading with this scale we get, whatever reading we'll get, we'll subtract this positive error because this quantity is positive. But in case of negative error, what we do, we'll get reading and negative error is calculated. So this is difficult part. So from, you can see from my example that it is starting from -3. So the -3 is the sub count, so we'll take -3, and if it is millimeter then we'll take millimeter, and then where this Vernier number is or Vernier count is aligning, so we'll take that x into Vernier count, and this value will be negative. So whatever reading we'll get, we'll subtract this and we'll get addition. So you need to be very careful in case of negative zero error, because there is an advanced question on this concept only, and most of the books I have seen that it is given wrongly. So we have to be very careful in case of negative zero error. Positive zero error we hardly do mistake in case of positive zero error, so this is not an issue. But in case of negative zero error, you need to calculate like this, or you calculate from the right side, from this side, which value is, which number, which sub count is aligned, and that is the value, minus of that value is the error, negative error. So you can do from a right side if you want to take into consideration of only the aligned number. But if you can also measure it like this, because this is -3 subdivision, and we can do normal measurement, so there is no issue about that. So hopefully this makes sense. If you have any doubt, please ask question.